Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on ring theory, lecture number 13, in which I will give the details concept of skew field or division ring. Let R with binary operation addition and multiplication is a ring. If we add some properties with this ring, number 1, having unity. Number 2, each non-zero element is a unit, that is, each non-zero element has multiplicative inverse. Then ring R with binary composition, addition and multiplication is a skew field. Now we write the definition of a skew field. Definition of skew field or division ring. A non-trivial ring S with unity is said to be a skew field or division ring if every non-zero element of S is a unit. Now I shall give example of a skew field. Example is the ring of real quaternions is a skew field. By solving, we will show that this ring is a skew field. Solution. Let H be the set of all real quaternions. That is, H be a set containing collection of 2 by 2 matrices whose entities are of the form here Z1, here Z2. Z1 and Z2 are complex numbers in which Z1 equal to of the form A1 plus IB1, Z2 equal to A2 plus IB2, A1, B1, A2, B2, all are real numbers. In the first row, we see Z1, Z2. In the second row, here we see minus Z2 bar, means conjugate of minus Z2. And this entity is conjugate of Z1. And collection of these types of matrices is called set of all real quaternions. We may verify that this collection is a ring with binary composition, addition and multiplication. Since H with binary composition, addition and multiplication is a ring. Now we see that whether unity exists or not. Let A1 equal to 1, B1 equal to 0, A2 equal to 0, B2 equal to 0, then Z1, Z2 minus Z2 bar, Z1 bar equal to Z1 equal to A1 plus IB1, Z2 equal to A2 plus IB2 minus Z2 bar is A2 minus IB2, Z1 bar is A1 minus IB1. Bar means conjugate. This equal to A1 equal to 1 plus I into 0. Here A2 equal to 0 plus I into 0. Here minus A2 equal to 0 minus I into 0. A1 equal to 1 minus I into 0. And this equal to 1, here 0, here 0, here 1. This is the unity of ring H with binary composition, addition and multiplication. Now, determinant of the matrix Z1, Z2 minus Z2 bar, Z1 bar equal to determinant of A1 plus IB1, A2 plus IB2 minus A2 minus IB2, here A1 minus IB1, and this is equal to A1 plus IB1 multiply A1 minus IB1 minus minus plus A2 plus IB2 multiply A2 minus IB2. This is equal to A1 square plus B1 square. This is A2 square plus B2 square. Let this is number 1, this is number 2. If Z1, Z2 minus Z2 bar, Z1 bar not equal to 0 matrix, then at least one of AIBI not equal to 0. Here at least A1 not equal to 0 or B1 not equal to 0 or A2 not equal to 0 or B2 not equal to 0. That is A1 square plus B1 square plus A2 square plus B2 square not equal to 0. That is determinant of Z1, Z2 minus Z2 bar, Z1 bar not equal to 0. That is each non-zero member of H is non-singular. That is, we may get inverse. Therefore, each non-zero member of H is a unit. Therefore, the ring H contains unity. Here each non-zero element is unit, hence H with binary composition, addition and multiplication is a skew field. Proved. Now we prove a theorem. Theorem is a skew field contains no divisor of 0. Now we prove this. Let S be a skew field. Therefore, S contains unity. Number 2, each non-zero element of S is a unit. Let A, B belong to S, A not equal to 0 and A multiply B equal to 0. This is number 1. Since A belongs to S and A not equal to 0 means non-zero element, therefore A is a unit, implies that A inverse exists, implies that A operation A inverse equal to A inverse operation A equal to unity element I. Let this is number 2. Now, given that A multiply B equal to 0 implies that A inverse multiply A multiply B equal to A inverse multiply 0. By associative property, A inverse multiply A multiply B equal to multiplication of any element with 0 element is 0. Associative property implies that A inverse multiply A equal to unity element I multiply B equal to 0. This is using 2. Implies that B equal to 0. Therefore, A not equal to 0, non-zero element, and A multiply B equal to 0, then B equal to 0. That means, therefore, A is not a left divisor of 0. Let B multiply A equal to 0, A not equal to 0 implies that B multiply A inverse equal to 0 multiply A inverse implies that by associative law B multiply A inverse equal to 0 multiply A inverse is 0. Here associative law implies that B multiply A inverse is unity element equal to 0, implies that B multiply unity element is B equal to 0. Therefore, A is not a right divisor of 0. This is number 3 and this is number 4. From 3 and 4, A is not a divisor of 0. Since A is an arbitrary non-zero element of S, therefore we may conclude that the skew field contains no divisor of 0. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.